other, and I'm literally just left with the number 1. Okay, over here, I've got a minus, and this, nothing cancels, but that's okay. I've just got x minus 1. And then on the bottom, x minus 1 over x minus 1, those cancel each other, and I'm left with the number 1. All right, by just multiplying by the least common denominator, look how much simpler I made it. Now I don't have fractions and fractions anymore. This is so much easier to deal with. Distribute your negative, so we get 1 minus x plus 1, and then over 1. I hope you guys are cool with me dropping that. So this will be 2 minus x. All right, so now I'm going to go back to my limit, because now if I were to plug in numbers, I'd be good. So this is now the limit as x approaches 1 of 2 minus x, which really just means 2 minus 1. So my overall limit is 1. All right, so we've got those 3 options: factoring, multiplying by a conjugate, or eliminating the denominator. We only have to do those if substituting doesn't work. All right, substituting is definitely our first thing that we try. Okay, a couple more things we have to talk about. I'm hoping this video isn't too long. I'm sorry. So some rules for evaluating limits algebraically. So let's take a look at what we've got written here. Suppose we have 2 functions, f of x and g of x, where the limit of f of x as x approaches a is just some number, L1. All right, I don't know what it is, but I'm just telling you that it's some limit. Okay, it could be 10 for all I care. Then we've got the limit of g of x as x approaches a is L2. Important thing to notice here is that both of these are limits as x approaches a. Okay, they have to be the same thing there. But what that means is if I take the limit as x approaches a of f of x plus g of x, then I can actually just break those up. And I can make it the limit as x approaches a of f of x plus the limit as x approaches a of g of x. So really, I'm taking the limit of the sum, which means I can just take the sum of the limits. I can break it up, all right? Don't overthink it. That means then, I don't have any room, sorry, I'm going to write it over here, but the limit of f of x as x approaches a is just L1. And then the limit of g of x as x approaches a is just L2, which means I can just add my 2 limits together. All right, this is really just some fancy notation for, hey, add the limits together. All right, very, very similar idea for subtraction. I can break it up to be the limit as x approaches a of f of x minus the limit as x approaches a of g of x, which really just means I'm making it L1 minus L2. I'm just subtracting my 2 limits. Okay? Limit as x approaches a of f of x times g of x. Guess what? We can just break it up to multiply the 2 limits. So limit as x approaches a of f of x times the limit as x approaches a of g of x, which really just means L1 times L2. Now, I know as I write these, you guys are probably like, what are we ever going to use this for? So I promise these 2 examples down below will show you. But we're able to use these limits then when we don't actually have the functions themselves. We just have some random values. Okay? So that's important for me to point out real quick. All right. Then we've got some division of limits. So same idea. The limit as x approaches a of f of x, and we can divide it by the limit as x approaches a of g of x. So that would be L1 over L2. However, this is very important. You have to make sure that L2 is not 0, because if it is, then we're dividing. So then we have to do some other fancy stuff, okay? When we've got the limit as x approaches a of the nth root of f of x, we can actually just take that nth root and shove it out. So it's the nth root of the limit as x approaches a of f of x, which really just means it's the nth root of L1. And then when we've got k, this constant in here, we can actually pop that out also. So we can make it k times the limit as x approaches a of f of x, which really just means it's k times L1. All right, I know that's a lot of letters. It's a lot of really weird stuff. So hopefully you've got it down. We're going to do these two examples, and if you're still confused, I promise we'll talk in class, okay? So now let's look at where this actually works and why this is something we have to even do. But the limit as x approaches 8 of f of x is -9. The limit as x approaches 8 is 2 of g of x. Sorry, I should have said that. The limit of g of x as x approaches 8 is 2. And then the limit of h of x as x approaches 8 is 4. So if you notice, I've got 3 different functions, but I'm looking at the limit as x approaches 8 for all 3. Okay, so we're going to take a look and see how we can actually solve a here. So I want the limit as x approaches 8 of 2 times f of x minus 12 times h of x. So the very first thing we're going to do is actually break up the two limits here. So I've got the limit as x approaches 8 of 2f of x minus the limit as x approaches 8 of 12 h of x. So all I did was use this second property that we talked about up here, the subtraction one. All right. Then if we look, we've got these numbers inside, so we can actually pop those out, which means now we're looking at 2 times the limit as x approaches 8 of f of x minus 12 times the limit as x approaches 8 of h of x. Well, now if we look, the limit as x approaches 8 for f of x, well, we know that value is -9. We also know, I can bring down my 2 then, and my 12, but we also know that the limit, let me move this down a little bit, as x approaches 8 of h of x is this 4. And now we can actually evaluate the limit, whereas before we couldn't. 2 times -9 is -18. 12 times 4 is -48. And then I can just put those together, and my limit actually is -66. So we just found this limit without even knowing what f of x, g of x, or h of x are. We literally just did it using these properties. Okay? One more, and then I promise we're done. I know this is a long one. So first thing we're going to do is break up that subtraction. So the limit as x approaches 8 of 3h of x minus limit as x approaches 8 of 6. All right, then pop that 3 out. So 3 times the limit as x approaches 8 of h of x minus the limit as x approaches 8 of 6. Now I don't want to pop the 6 out because there's no function there with it. So I could pop the 3 out, no problem. And then I can see that, oh, here's my limit of h of x. So I know that that right there is going to be a 4. And I'm going to have a 3 multiplied by it. But the problem is I need to know what the limit of 6 is as x approaches 8. So what I want you guys to think about is maybe up here at the top, let's remind ourselves that 6, if I've got y equals 6, that's just a horizontal line at 6, which means if I'm at x equals 8, my limit has to be 6. All right, anytime you've got this constant function, then the limit is actually just the constant. Okay? So here we've got 12 minus 6. And so our limit is 6. All right, I know that was a lot. I know it was a lot of notation. So hopefully you guys were able to follow along okay. On Monday in class, I will answer any questions you guys have. I will help you out with whatever it is you need. All right, I hope you guys have a good rest of your weekend, and I'll see you Monday. Bye.